Welcome to our channel Learning Math. In this video, we're going to solve the second part for the official math exam 2021 for grade 9, the first session. Before starting and for the continuity of our channel to support you by more and more information, please like, share and subscribe with a great appreciation for your support. Now let's start together by the questions of analytic geometry and geometry. Well, in the first question for analytic geometry, we have in an orthonormal system of axes x prime or x, y prime or y, the points A of coordinates 1, 4 and the point B of coordinates 5, 2. In addition to a straight line D of equation y equals to x plus 2. We have to plot the points A and B, verify that A is a point on D, then draw the straight line D. Well, to prove that A is a point on the straight line D, we just need to solve 2xa plus 2. We should prove it equal to ya. Note that xa is equal to 1. We can just replace it by 1. Then 2 times 1 is 2. Plus 2, it gives us 4. Isn't it equal to ya? So we can say that the coordinates of A satisfy the equation of D, therefore D passes through A. Or we can say A belongs to D. Well, if you know something, we have just found the first particular point on the straight line D, which is A. So we just need to find only one other point. If we take, for example, for x equals 0, y equals 2x plus 2, so it's 2 times 0 plus 2, it gives us 0 plus 2, which is 2. Then the second particular point has the coordinates 0, 2. Well, here we have plotted the points A, 1, 4, B, 5, 2, the particular point 0, 2, and when we join it with the point A, we get the straight line D. Well, now let D prime be the perpendicular through B to the straight line D. Prove that its equation is minus half x plus 9 over 2. Then verify that D intersects D prime at A. Well, D prime is perpendicular to D through A. We start by its general form of its equation y equals ax plus b. Well, we have two information in this given which are very important for us to find the equation of D prime. First of all, perpendicular gives us product of slopes is minus 1. Well, in the general form of this equation, we have two unknowns which are A and B. The slope A, we can find it directly from the product of the slopes, which is minus 1, while the unknown B, we can find it from the particular point, which is given here, the point B. Now let's start together. They are perpendicular, then the product of the slopes is minus 1. We just replace the slope of D by its value, which is given 2. Then we can say that the slope of D prime is minus 1 over 2. Since here, when we move 2 to the other side, times becomes divided by. Well, we can then replace the slope of D prime in the equation of D prime. We just replace A by minus half, so y equals minus half x plus b. Now we are still having one unknown, which is b. To find it, we have to say that D prime passes through the point B, then the coordinates of B satisfy the equation of D prime. So we can replace in the equation of D prime, instead of y, we write it yb equals minus half. Instead of x, we write it xb plus b. Now we just replace the coordinates of b by their values. We have given that yb is 2 and xb is 5. So we can say that 2 equals minus 5 over 2 plus b. Here sure 5 is 5 over 1. We multiply numerator by numerator. 5 times 1 is 5. And denominator by denominator, 2 times 1 is 2. Now we move minus 5 over 2 to the other side to find the value of b. We can say that b is 2 plus 5 over 2. It gives us 9 over 2. Therefore, the equation of the straight line D prime is y equals minus half x plus 9 over 2. Now to prove that D and D prime intersect at A, we have two methods. The first method is to find the intersection of D and D prime. When we solve y equal y, we get the coordinates of their intersection the same as the coordinates of A. But the second method, we have just proved that A is a point on D. If we prove it a point on D prime, then it will be an intersection point to both lines. So if we solve the equation of D prime, we replace minus half x by xa here plus 9 over 2, we get it equal to ya. Now let's replace x by xa. We have xa is given 1, so minus 1 over 2 times 1 is minus 1 over 2, plus 9 over 2 we copy it. Same denominator, we add in numerators, minus 1 plus 9, which is 8. 8 over 2, it gives us 4. Isn't it equal to ya? Well, in this case, we can say that the coordinates of A satisfy also the equation of the straight line D prime. Then D prime passes through A. But since D passes through A, then we can conclude that A is the point of intersection of D and D prime. Well, also if we solve y equal y, we will get the coordinates of the point of intersection the same as the coordinates of A. Both methods are correct. Now let's start by the next part. We have the straight line D intersects x prime or x at a point E. Calculate the coordinates of E, then prove that triangle AEB is right isosceles at A. First of all, we have the straight line D intersects x prime or x at the point E. Well, we cannot find the points of E graphically. Sure, it will be exactly minus 1, 0, but we cannot find its coordinates graphically. Now, how to solve it? If you know something, E is a point on x prime or x. Can't we say in this case that ye equals 0? On the other hand, E is a point on the straight line D. Then the coordinates of E will also satisfy the equation of the straight line D. So first of all, we have to say that E belongs to x prime or x, then ye equals 0. E also is a point on the straight line D, then ye equals to xe plus 2. We replace y by ye and x by xe since its coordinates satisfy the equation of D. Now ye, we have just proved it 0, then 0 equals to xe plus 2. Now if we move plus 2 to the other side, it becomes minus 2, so we can say that 2xe equals minus 2, then xe equals minus 2 over 2 is minus 1. Therefore, E has the coordinates minus 1, 0. Now we have to prove that triangle AEB is right isosceles at A. If you know something, since D and D prime are perpendicular, we can directly say that triangle AEB is right at A. These two lines are perpendicular at A. Also, we have E is a point on D and B is a point on D prime. So we can say that this triangle is right at A. We have just to prove it isosceles. Well, how to prove it isosceles? We just need to find the length of AE and AB and prove them equal. Now let's start finding these lengths. We have that AB equals radical xb minus xa square plus yb minus ya square. We can just replace the coordinates of A and B by their values. We have xb, which is 5, minus xa, which is 1. Also, we have yb, which is 2, minus ya, which is 4. Then here, 5 minus 1 all square, which is 4 square, it gives us 16. Also, 2 minus 4 square gives us minus 2 square minus, when we have even power, becomes a plus, so it's a plus 4. Now, 16 plus 4 is 20. We simplify radical 20, it gives us 2 radical 5. The same for the length of the straight line AE is radical xe minus xa square plus ye minus ya square. If you know something, we have xe, which is minus 1, minus xa, which is 1, minus 1, it gives us minus 2 all square. Also ye minus ya, it gives us 0 minus 4, so it's minus 4 here all square. Since we have a square, minus becomes a plus, so it will be plus 16. Now radical 4 plus 16 is equal to radical 20. When we simplify it, we get AE equals to radical 5. Note that in this case, AB and AE have the same length, they are equal. Therefore, since EAB say length equal 90 degrees, triangle BAE is right isosceles at A. Let J be the midpoint of EB. There's something which is very important here. We need to analyze the given. Denote by F the symmetric of A with respect to J. Then prove that AEFB is a square. Well, first of all, we have J is the midpoint of EB. We have F is the symmetric of A with respect to J. Can't we say also that J is the midpoint of A, F by symmetry? If you know something, J is at the same time the midpoint of EB and the midpoint of A, F. In this case, we can say that the diagonals bisect each other at J in the quadrilateral AEFB. Then this quadrilateral will be a parallelogram. But note something, it has a right angle. Then we can say that it's a rectangle. Parallelogram having angle 90 degrees becomes rectangle. But also in this rectangle, we have the adjacent sides AB and AE equal. We have just proved them equal both to radical 5. Therefore, we can say that the quadrilateral AEFB is a square since it's a rectangle having equal adjacent sides. Now let's start by the question of geometry. We have a circle of center O and radius 3. AB is a diameter in this circle. We also have M is a point on AB such that OM is equal to 5. Also, we have the line AG is perpendicular to ME at G. We have note that ME is the tangent to this circle at E, and AG is perpendicular to this tangent. Now draw the figure, verify that ME equals 4. Note that triangle MEO is right at E. Since we have tangent, it will be sure perpendicular to the radius OE. Can't we apply Pythagoras Theorem? But the radius OE is also equal to the radius which is given 3. So we just need to find the value of ME. So this triangle is right at E. Then by Pythagoras theorem we can say the hypotenuse squared, which is MO squared, is equal to the sum of the squares of these sides, which are ME squared and EO squared. Now we just replace them by their values. So MO squared, which is 5 squared, 2 plus 3, is given also 5, equal ME squared plus EO squared, which is 3 squared. So 25 equals ME squared plus 9. Now we can move 9 to the other side. Plus becomes minus. So 25 minus 9 equals ME squared. Then ME squared equals 60. Well, keep in mind, to remove square, we need to put plus or minus radical. ME equals plus or minus radical 16, so it's plus or minus 4. But sure minus is rejected since we have length. Therefore, we can say that ME is equal to 4. Now show that ME over MG equals 5 over 8. Then deduce the values of MG and AG. Note something which is very important. We have OE and AG are perpendicular on the same line, which is MG. Then we can say that these two lines are parallel to each other. Can't we apply Thales property in this case? So by Thales theorem, we can say that ME over MG is equal to MO over MA. Note that MO is 5, it's 2 plus 3. MA is 5 plus 3, then it's 8. So it's equal to 5 over 8. Now we have to find the values of MG and AG. Note that ME is 4, we have just proved it, so we can replace it by its value. So it's 4 over MG, ME, sorry, not MG is 4. 4 over MG equals 5 over 8. We can perform here cross multiplication. Then we can say that 5 mg is equal to 4 times 8, which is 32. Therefore, mg equals 32 over 5, so it's equal 6.4. Now, what about ag? Also, we can say by Thales property, this ratio is also equal to OE over AG. Well, we have OE is a radius, is equal 3 given. We can replace it by its value. Then we can say that 3 over AG, here we replace OE by 3. 3 over AG is equal to 5 over 8. Also, we perform cross multiplication by the same method. We prove that AG is 24 over 5, so it's 4.8. Now let F be the orthogonal projection of E on AM. Orthogonal projection, so we have perpendicular. Prove that the 4 points F, E, G, and A are on the same circle. Well, as you see here, the orthogonal projection of E on MA is F. We need to prove that F, E, G, and A are the 4 points are on the same circle. Note that when we are counting these points, we have an angle 90 degrees at the vertex F and another angle 90 degrees at the vertex G. Can't we say here we have two right triangles having the same hypotenuse, which is EA? Then the four vertices here, F, E, G, and A, are on the same circle whose diameter is EA, and sure, the center of the circle is the midpoint I of this diameter. They are asking us to determine the center of the circle. We have just determined it. Now the parallel through A to OI intersects OE at L. This is also very important. Note that I, we have just proved it the midpoint of the hypotenuse. We have a midpoint. We also have parallel through A to OI, parallel to the through the midpoint. It intersects, this parallel will intersect OE at L. Prove that L is a point on this circle. Sure, we have to analyze the given. I is the midpoint of EA. We have from I the parallel IO to the straight line AL. Parallel, and we are having it issued from the midpoint. Can't we apply in this case the converse of midpoint theorem? Sure, in triangle EAL. By converse of midpoint theorem, we can then conclude that O is the midpoint of EL. But note that E is a point on this circle, and O is the center of this circle. O is also the midpoint of EL. Then L is a point on this circle. We can say in this case that E and L are diametrically opposite to each other. Thank you for watching. If you enjoyed this video, please like, share, and subscribe.